Alright guys, Mr. Shaw back again. I tried to get Mr. Haltman to come and do a guest appearance and he would do the rest of this video, but he said that he didn't feel like it, so I guess he just doesn't like you guys as much as I do. So let's get to it. 3 problems, a little bit different, but this first one's just going to be another graphing example, so let's get to it. So again, we're going to separate these two terms. Again, we can just kind of group them together. I'm going to do that in the actual equation though this time. So here we know that we can take out a -2 from this little group here. So it'll be y equals -2, and now instead it's going to be, again, remember it changes this middle sign, so it'll be x squared minus 2x. Okay, I'm going to leave some space, plus 1. And again, from this, again, we're going to do b over 2 squared, so -2 over 2 squared. -2 divided by 2 is -1. -1 squared is +1. So I'm going to add 1 inside the parentheses. So again, add 1. So you have to do 1 times -2. So you're going to subtract 2 from the other side. But again, we need the y by itself. So I'm actually going to just add it over. So add 2 over here. So it's going to be y equals -2 times x minus 1 squared plus 3. So let's go to our vertex. Again, our vertex is going to be inside's opposite, so 1, 3. So right here. And then the a is -2. So 1a is -2. 3a is -6. So over 1 down 2. The other way, the same thing. And then over 1 down 6. So right here. Alright, and again, we'll just go ahead and terribly graph it. That's not too bad. Alright, and there you have it. Okay, again, that's our last kind of graphing one we're going to do. The other one is we're going to kind of go backwards, and it's going to give us a graph like this, and it's going to tell us to write an equation in vertex form from the graph. So it's pretty easy, but there's one little misstep that people mess up on a lot. So let's go ahead, let's give it a shot. So I can, again, it gives me the vertex, so it's 2, -7. So I know that the equation, I tell you what, I don't know if I can move this real fast. Let me move this. Nope, of course not. Here we go, hang on 1 second. Moving. Okay, good, got it, sorry. Moving. Alright, got it, sorry to waste your time. Okay, so anyway, now again, I know that vertex form is this. So y equals a times x minus h squared plus k. So again, the only value I really am not going to be able to tell immediately anyway from the graph is this a value. So I'm going to show you the hard way to do it, and then I'm going to show you the easy way to do it. Okay, so again, I know that my x is going to be, it's +2, so it's going to be x minus 2 squared, and then my k value is -7, so it's going to be -7. So again, and then it's y equals a. Now in this case, the other point it gives me, again, this is just used to find whatever the a value is. So again, I'm going to show you the way to figure it out algebraically, and then we can kind of look at the graph and maybe we'll get lucky and figure it out that way as well. So anyway, I'm going to plug in 4 and 5. So I know it's going to be y is 5. So 5 equals a times 4 minus 2 squared minus 7. And I'm going to solve for a. So here, again, 4 minus 2 is just 2. So it's going to be 5 equals a times 2 squared minus 7. 2 squared is 4, so it's going to be 4a minus 7. So I'll add 7 over here. Cancel that out. So it's going to be 5 plus 7 is 12. So 4a, 12 equals 4a, so divide by 4. So a equals 3. So now I can rewrite my final answer as far as my vertex form goes. So it'll be y equals 3 times x minus 2 squared minus 7. So that's my answer. Now, I could have seen that from the graph in this case. If you look, if you went, again, because you know you go over 1 and then up whatever the 1a is. So I go over 1 and then up 1, 2, 3. it looks like. Now, if it actually is 3, I would go over 1 and then up 9. So over 1 up 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so clearly we could have told just from this alone that A equals 3. Again, it's good to have this algebra though behind it because our eyes can deceive us. I might make a problem that isn't exactly easy to tell. So you want to be able to have the algebra to back up on. All right. So one more problem, and then I'm going to call it a day. So anyway, let's get to it. And in this case, what I just said, it's a little bit harder to tell with when it's a compression. So anyway, you want to make sure you always have that algebra. All right. So anyway, here we go. We know again that it is y equals a times x minus h squared plus k. And it tells us the vertex is negative 2, 3. So I can fill it in. So again, I know that y equals a times x. Now minus 2 here. Again, remember it's always opposite. So I'm going to write minus negative 2 squared plus, not k. Why would it do that? Minus negative 2 squared. And then it's going to be plus 3, which is the y value. So again, minus a negative is the same thing as plus a positive. So now it'll be x plus 2 squared. And now I can just go ahead and again plug in my points, plug in this other point and see what this a value is going to be. So again, y in this case is going to be negative 1 equals a. X is 1, so 1 plus 2 squared plus 3. So negative 1 equals a times 3 squared plus 3. 3 squared is 9, so it's going to be negative 1 equals 9a plus 3. So I will go ahead and subtract 3 over. So negative 4 equals 9a, divide by 9. So a equals negative 4 over 9. So again, it's a lot more difficult to tell, like I said, with the fractions, just because, like I said, you might have thought going in that it was like, okay, over 1, it looks like it's kind of like a half, but again, you can't just assume that. That's why you want to definitely have that algebra to back it up. So anyway, I'm going to fill in my final answer here. It'll be y equals negative 4 over 9 times x plus 2 squared plus 3. And that's it. All right, guys, I'm all done. I'll catch you on the flip side.